Concept and definition of differentiation. One of the most important concepts in calculus. A process of finding a function that outputs the rate change of one variable with respect to another variable. An action of computing a derivative. The derivative of a function y equals function of a variable x is a measure of the rate at which the value y of the function changes with respect to the change of the variable x. Derivative of function with respect to x. Derivatives are a fundamental tool of calculus. Concept and definition of maximum and minimum problems. Many application problems in calculus involve functions for which you want to find maximum or minimum values. The restrictions stated or implied for such functions will determine the domain from which you must work. The function, together with its domain, will suggest which technique is appropriate to use in determining a maximum or minimum value. The extreme value theorem, the first derivative test, or the second derivative test. The process of finding maximum or minimum values is called optimization. Optimization problems such as maximizing profit, minimizing the amount of material used in manufacturing an aluminum can, or finding the maximum height a rocket can reach.
What is applied maximum and minimum problem? The process of finding maximum or minimum values is called optimization. For example, it is used to maximize the profit in a company or to minimize the cost, and to find the least amount of material to make a particular object. There are 3 steps on solving maximum and minimum problems. Firstly, find the derivative. Secondly, let the derivative equal to 0 and find the values of the variables. Thirdly, do the second derivative test. If second derivative is bigger than 0, you must find the minimum values. Otherwise, if the second derivatives are lesser than 0, you must find the maximum value.
A rectangular plot of land is to be fenced using 2 kinds of fencing. 2 opposite sides will use heavy-duty fencing at the cost of 6 ringgit per meter, while the remaining 2 sides will use standard fencing at the cost 4 ringgit per meter. If the total cost of fencing a rectangular plot is 1,200, find the dimensions of the rectangular plot of the greatest area. Now we know the problem statement. Let's solve it.
Step 1. Draw a rectangular plot of land and label. You have to label X for the width and Y for the length. Step 2. Find a formula for the quantity to maximize. Like the question said, 2 opposite sides will use heavy-duty fencing at the cost of 6 ringgit per meter, while the remaining 2 sides will use standard fencing at the cost 4 ringgit per meter. If the total cost of fencing a rectangular plot is 1,200 ringgit, right? So, 2 multiply 4x plus 2 multiply 6y equals to 1,200. Then, multiply it, you will get 8x plus 12y equals to 1,200. Then, solve it, you will get x equals to negative 3 per 2y plus 150. Step 3. Identify the quantity to be maximized as a function of one variable. Area A equals to xy. We already got the x value, so negative 3 per 2y plus 150 open bracket y and close bracket. Then A equals to negative 3 per 2y square plus 150y. It became y square because the y on the outside of the long bracket already multiplied to the equation. Step 4. Find value of y when dA over dy equals to 0. So, dA over dy equals to negative 3y plus 150. Then solve it. Negative 3y plus 150 equals to 0. Then negative 3y equals to negative 150. Then y equals to 50. Step 5. Find d square a over dy square and substitute y from step 4 to difference between maximize and minimize value. So, d square a over dy square equals to negative 3, that is the maximum value. Then, this is the last step. Step 6. Determine value of x. X equals to negative 3 over 2y plus 150. Then, negative 3 over 2 multiply 50 plus 150. Then, negative 75 plus 150. And you will get the value of x, which is 75. So the answer is x equals to 75 meter, y equals to 50 meter. That is the answer for dimensions of the rectangular plot of greatest area. You did great! Now, we have come to the conclusion. So, what do you guys get from this topic? After studying this topic, we must know and able to understand the idea of differentiation and find a suitable formula or method that fits the question given. The fields of the use of calculus are very wide. It enters into many fields and are not limited to specific people or to those who use it only, but to almost all human beings. Integration is not only a mathematical term, but it is given a way to solve a problem in real life. With such ability to describe the real world, being able to solve differential equations is an important skill for mathematicians. Differential equation is mainly required, and to solve that, we need differentiation and integration. Differential equations and equation involving derivatives of a function or functions have a remarkable ability to predict the world around us. We can conclude that minimum and maximum problems can solve using second derivatives method. The question of practical applications of integrations in daily life. Integral calculus or integration is basically joining the small pieces together to find out the total. That's all from us, guys. We hope you guys can understand and learn this topic from our video. Thank you for watching, and do not forget to like and share our video.